This mini tutorial is going to walk through some example problems in the formula mass and the mole concepts section of Unit 2 in your textbook. So when you're completing any of these mole problems, I would recommend printing out this document, which is something that I created just to kind of help you with the conversions in the mole. Kind of have that out, and that'll help you as a guide as you're working through these problems. And I will be referencing to it as well during these this section of tutorial. So the example that I picked is from this section of the textbook up here that I had just said, and you can just follow along with your textbook after you review this or after you work through some of the examples. So example 4 I jumped to, it asks, what is the mass of 2.561 moles of gold? So I'm given this information and I'm asked to find the mass. Okay, so what I would do is take a look at this chart. I am given moles and I'm asked to find grams. So I don't even need to be on this section of the chart right now. I'm just doing a conversion from moles to grams. And this gives me my conversion factor. 1 mole is equal to, how I find my grams is by going to the periodic table and looking up the molar mass. Okay, so molar mass, you should know from earlier in the unit, is going to be kind of your tiny number underneath the element name. That's your molar mass. That's what we'll be using. Okay, so we're going to go ahead and start with our 2.561 moles of gold. And I am going to do my conversion. Since moles of gold is on top, I'm going to put moles of gold on the bottom so I can get that unit to cancel. And the unit I'm converting to is grams of gold. The way you use this chart is, since moles and grams are right next to each other, then that can be done in one conversion step, moles to grams. Okay, so again, according to this, wherever I see moles, I'm going to put the number 1. And wherever I see grams, I have to look at the periodic table to find the mass. It'll be specific for the element or compound in my problem. So I'm going to go ahead and look up gold on my periodic table, and I will find that it is 197.10. That number might change slightly based on the periodic table you're using, but I use the periodic table that's in your own textbook. So that's what you should get if you're looking at that. Whenever you go and solve, this is the number you'll get. You need to round to correct sig figs. 95% of the time for these problems, they're just going to be the number of sig figs that were in your original number given to you. So that has 4 sig figs. So in order to round this number to 4 sig figs, I'm going to have to take this 7 up to an 8, and then that's it. All right, then I jump into example 6 in your textbook. It says how many moles of sucrose, and it gives you the chemical formula of sucrose, are in a 25-gram sample of sucrose. Okay, so in this case, I'm told I'm given 25 grams of sucrose, and I want to know how many moles of sucrose that is. So again, according to my conversion chart, grams to moles, this is just going to be a one-step conversion because they're right next to each other. All right, so if I start with my 25 grams of the C12H22011, okay, I want to get rid of grams, so since grams is on the top, I'm going to put grams on the bottom in my next step. And I can convert directly to moles because those 2 units are right next to each other on the mole conversion chart. Right, so I always, when I teach this, I always say fill in your units and then fill in the numbers after you've put the units where they go. Again, taking a look at this chart, wherever the unit moles is, that's where I'm going to put the number 1. And this problem, moles is on top, so that's where I'm going to put the 1. And wherever grams is, that's where I'm gonna have to look at the periodic table. If we go through and break apart C12H22 O11 and add those up individually, we will get a total of 342.296. The textbook does, in my opinion, a great job in teaching you and walking through step by step how to add up molar masses. So please make sure to refer to that and really look at that and all of the examples, because I think that there's really no question on how to do that whenever you're done looking through that. So once you do that, then we're going to go ahead, put that in our calculator. You should get something like this. We need to round it just to 2 sig figs. So rounding that number to 2 sig figs is going to be 0.073 moles of the C12H22O11. Okay. All right. This next example is just one that I wrote. I didn't I thought there was another extra one I wanted to do before jumping into our other example. And this one asks, how many molecules are there in a 5.46 mole sample, that should say, of H2O? And I want to know how many molecules. So I'm converting from moles to molecules. If I look at this conversion chart, moles is in the center, molecules is on the right here. So I'm not using grams at all in this problem. I'm just going back and forth between these two. And I've gotten some questions on that. Some students are like, where do I put in grams? There's some of these problems where you won't need to do the grams. And this is one of those examples because we're just converting back and forth between these two. So you can see there's no mention of grams at all. It's not till we get to this other side that you need to go to the periodic table. So that's why I wanted to do one of these to show you that there will be instances where you will not need grams. Okay, so we're going to go ahead and start with our given, which is 5.46 moles of H2O. Just a quick side note, MOL is the shortcut for mole, M-O-L-E. It's not that much of a shortcut, but that's what we do use in chemistry. Okay, set up my conversion. Since moles is on top, I'm gonna put moles on the bottom. And since moles to molecules are right next to each other on the chart, then I can go ahead and do that moles to molecules conversion in one step. Molecules, I'll normally just abbreviate that MOLEC so it doesn't get confused with mole, which is something different. Okay. So putting my units in first, now my numbers go in with moles, wherever the unit moles is, that's where the number 1 goes. So since moles is down here, that's where I'm going to put the 1. And then molecules gets 6.022 times 10 to the 23rd. I go up a little here, I'm running out of room. Okay. And now I can go ahead and solve. I put a little note to you on this, on the mole conversion chart. Watch how you put that 6.022 times 10 to the 23rd in your calculator. 95% of the students who miss these problems do so because they try putting that in using like a caret or a times or whatever. You want to use the actual exponential key on your calculator. So for this example, I'll show you how you would input it. Yours might look slightly different, but kind of same idea. So I would put in my 5.46, and then I'm multiplying that by the 6.022 times 10 to the 23rd. The way that goes in is you hit 6.022. Don't hit times. What you're gonna do is find that large double E button on your calculator. That's called an exponential. That's what you wanna look for. And depending on your calculator, it's gonna be in a different location, but that's what you wanna find. After you put in 6.022, then you just hit that E button. I don't say times E, That is the hugest, biggest part. That'll throw off your answer every time. So it should just say 6.022 E, and then our power, which is 23. There's no times, there's no 10, there's no caret. It's just that E button, and then press enter. That's what I see. This needs rounded to 3 significant figures, so it'll be the 3.29. Do not forget to look at the very end. I also need that to be times 10 to the 24th. So whenever I go to record that answer, we'll have 3.29 times 10 to the 24th molecules of H2O. Okay, and now those are examples of one-step conversions using the moles. Okay, again, moles to grams can be done in one step. Moles to atoms, moles to molecules, moles to formula units, any of those can be done in one step.